My dear students, a very good morning to all of you. Today we discuss about what is electric flux. Electric flux we can understand with the help of one example. Let us suppose the wind is coming from a window and it having a certain speeds. So we can find out how much the wind is coming from the window. So this is depends on two things. What is the area of the window, and another is one, what is the speed of the air. When we find out these two things, then we calculate the air is comes from the window. So we can define as, from this example, the rate of flow of wind is given by the volume crossing the area per unit time, represent the flux. In terms of another examples we take, we stored a water in a bucket. That means this is a scalar quantity. We can only measure. So we have 10 liter. Let us suppose we have 10 liter volume of water. But if we find out what is the directions of this water, then for find out the directions, it should be flow. So these examples with we can explain electric flux. Electric flux means electric flux is linked to a surface area, is a quantity formed by intensity of field. And what is intensity of field? Intensity of field means electric field lines in per unit area. That is intensity of field. How much the electric field lines over a unit surface area, that is the intensity. And we can say electric flux is linked to a surface area, is a quantity formed by intensity of field, electric field, and area normal to it a. That is very important. Area is normal to it a, such that flux linked to a surface area is phi E is equal to E dot A. Let us suppose we have a uniform electric field and its direction should be in this directions, and A is we have area of a surface. A is surface area. Then by the definition, intensity of field E, here we have intensity of field E, and area normal to it. We count it. Let us suppose this area is unit area and we count the electric field lines. Here we have 1 2 3 4 5 6. That means this 6 is the flux linked with this surface area. So we can write as flux is equal to intensity of E multiplied by area linked. Got it? If unit area, then we counting this, and this is the flux linked with this unit area. Another case we have, if we tilt this surface, and or we can say this area, so here we have, after tilt, its position should be this. Now what is the value of electric flux? It will decrease or it will increase. So if we tilt this area, then we see in this figure it is also uniformly uniform electric field. So here we see electric flux will decrease. So we can write flux is equal to intensity of electric field multiplied by area linked. Now here when we tilt this area, it makes an angle theta. it makes an angle theta with surface. So this angle is theta, then it is also a theta alternate angle. Now, what is the value of this line? We can write as whenever a, whenever a line is along to the angle, or we can say along to the theta, that should be a cos theta. Now we have flux is equal to E dot A cos theta. So phi E is equal to E dot A cos theta. This is after tilt area, then we got this expression. But in general, we have a formula phi E is equal to E dot A. Another examples, another situations we take. Let us suppose in this example or in these conditions we have electric field is not uniform. Here electric field is different, electric field distributor are different. So for here we have, let us suppose, a very small surface, that is ds. Here we have consider a small surface, that is ds. So many surface this in these conditions. Area vector always radially outward to the surface. Area vector is always radially outward to the surface. That means it is the direction of area vector. Let us suppose we have here is very small area, so we can find out d phi is equal to E dot ds cos theta, and phi is and suppose we have so many let us suppose we have a cylindrical surface. For a cylindrical surface, how we can find out the electric flux? We consider in a cylinder we have three surfaces. One is flat surface and other is curved surface. One curved surface and two flat surfaces. So we can find for each surface flux linked with area is different. Now for example, let us suppose we have electric flux is in this directions and electric flux is in this directions, and we have a surfaces here, and this is electric field directions and this is surface. So what is the flux there? We already discuss, or we already tell, area vector is normal to the surface, radially outward. Area vector is normally to the surface. That means this is area vector. So it makes an angle theta. It makes an angle theta. That theta is 90 degree. So we have formula phi is equal to E ds cos of theta, and we put theta is equal to 90. So cos 90 is equal to 0. So phi is equal to 0. It's mean whenever a problem we have electric field along the surface, then flux linked with this surface area is 0. But if we have another conditions, if electric field is in this directions and surface is this is surface, so electric field in this direction, and we know the area vector is radially outward normal to the surface. This is area vector. So here we have angle between E and A is theta is equal to 0 in this condition. So we have phi is equal to E dot ds This is flux linked with this surface whenever surface is normal to the electric field. So this is that mean why it is important. Area normal to it A. Area normal to it A means area here will normal to the surface. So this is the electric flux.